discuss, and then we'll move on to the how to represent the various signaling schemes in this particular code. Okay. One minute, I'm adjusting. Okay. This overview of, first we'll see. 1 minute. Overview of HDB coding. First, let us see what exactly this coding is, and then later we'll move on to the next types of codings which are available in this. What is this HDB coding is? High density bipolar. HDB coding is nothing but high density coding. Density bipolar coding. Students, this high density bipolar coding, it is also in short, it is represented as HDB coding. So this HDB coding, or you will say it is signaling. Coding or signaling, it is one and the same. Why this type of coding we are using? First, let us discuss, and then we'll go for the problems to solve using this particular coding technique. So this question has been asked in July 18. So 2018 question paper, you can see. So it is 6 to 8 marks question. Definitely will be there on this type of signaling format. This is an advanced signaling format we'll be using in the digital communication whenever we are transmitting these signals before over the communication channel, either before the modulation. When you look at this particular high density bipolar signaling scheme, the very first question which arises for us is that why do we go for high density bipolar coding when we have bipolar? As let us review what this bipolar coding or bipolar signaling is, which we have in detail discussed in the previous classes. What is this bipolar coding? Again, there are two types of codings we'll be seeing: non-return to zero and return to zero. Irrespective of whether it is a return to zero or non-return to zero, what exactly this bipolar coding is? How do you represent x of t? Yeah, please tell me. How do we represent the x of t in bipolar coding? It's also called as AMI coding. What is that AMI coding is?
Whose amplitude is plus or minus a for symbol 1.
Yeah, its amplitude will be plus or minus a for symbol 1, and for symbol 0?
It is 0.
0 for symbol 0. So this is how we will be representing the symbol 0 or symbol 1. That is, if you take 0, 1, 1, yeah, 0. Suppose if you are using bipolar coding, how do we represent 0 with 0? So suppose first bit is positive, next bit will be negative amplitude and 0. So this is how the inversion technique we'll be using in bipolar coding. So 3 amplitudes we'll be using in this type of coding. Suppose this bipolar coding you are using. In this bipolar coding, you usually will consider the bit stream. Bit stream means zeros and ones combination, is it not? So these zeros and ones, when we are transmitting, suppose the information consists of long series of long series of zeros. Then what about the channel? Most of the time on the channel, what you will be observing? On channel, no signal you can see on the channel, is it not? Students, whether yes or no? Hey, are you there or not? Are you relaxing?
Yes.
Yeah. Yes. When there is an series of zeros, suppose it may be 4 or it may be 10 or it may be 12, the information what you are going to transmit after the binary conversion sometimes may have the sequence of zeros. When these sequence of zeros, when they are transmitted over a channel, most of the time we'll see that channel, even though there is a zero transmission, we'll feel that there is no signal which is getting transmitted over the channel. So to avoid all these things, because whether the channel there will be a doubt when the user or the reconstructor starts reconstructing such signals. During the reconstruction, the signal we may think that whether it is whether there is an information which is getting transmitted or not. So in such cases, how to identify the information, whether it is an channel with no signal or channel with signal having a series of zeros in the bit stream. To identify that one, the technique what we are going to adopt is the high density bipolar coding. So high density bipolar coding. In this high density bipolar coding, the number of zeros will be monitored. Zeros are monitored. If suppose these monitored, and if number of zeros are zeros are 3, or it may be n. So then it may be more than 3, or it may be n number of zeros. If number of zeros are, we will add a positive pulse or negative pulse at the beginning or at the end of bit zeros trailings. Okay, this is what we'll be doing in case of the signaling scheme. If suppose there is a number of zeros which are very continuously zeros are more. If the another problem why we have gone for this type of high density bipolar coding is that whenever zeros are getting transmitted over a long period sequence of zeros, then synchronization will become problem. Will be a problem. What do you mean by synchronization? Because at transmitter, what clock you are going to make use, the same clock at receiver you need to make use. Because here when this high density bipolar technique, when it is not used, if suppose it is going like zeros completely with the absence of signal at the receiver, synchronization will become problem, because with respect to the transmitter, when reconstruction has to be done, will be a difficult task. So hence we will go for high density bipolar coding. In this, the problem of no information on the channel or the synchronization to establish between the transmitter and the receiver, we are going for HDB coding. In this HDB coding, what exactly the principle we are going to adopt means, in HDB coding, the zeros, number of zeros are monitored. And based on the number of zeros, how many they are getting transmitted, we will be using this HDB N coding. Okay, where this N represents, it may be 1 or 2 or 3 or 4, etc. Up to N number of bits. So all these belongs to a bit stream X of T. If suppose, for example, if you take N as equal to 3, then it is represented as HDB3 coding. Clear, students? Yeah. In this coding, suppose you have N plus 1 zeros. Whenever there are N plus 1 zeros occurs, the special signal will be added. So hence it is termed to be the HBD coding. Suppose you have N plus 1 zeros. Okay, there will be N plus 1 signals, but not the complete zeros. So this type of N plus 1 signals conversion for N plus zeros is termed to be the high density bipolar coding. And one coding which we are going to make use is only the bipolar, not the unipolar or not the Manchester or the polar, because polar also will have continuously the amplitudes. Bipolar, unipolar also off on signaling. It is also termed as on off signaling. But when you go for bipolar, in that bipolar, because three amplitudes we are using, synchronization will be a difficult task. To overcome this, what we'll be doing, this HDB3 coding we are using. In this HDB coding, what exactly we'll be doing? So first let us discuss, and then there is one signaling scheme. Okay. 1 minute, 1 minute. In this signaling scheme, which scheme we are considering? HDB3. So this 3 represents consecutive 3 zeros. Anything you can take, 6 zeros you can take, 8 zeros you can take. There is a different formatting template you have to follow. When 3 zeros are existing, then how do the spectrum or the signaling scheme we are going to convert? Please listen carefully. Here signaling scheme will be as follows. What exactly? There are different cases you need to consider. There are 4 cases, and the number of, based on number of ones and previous bit status, the present sequence bit will be placed. Suppose the first case, let us take the number of ones in a sequence, that is previous. It is number of ones what we'll be considering. It is before these zeros starts, number of ones you need to consider. In this, if suppose we have an odd number of ones and the previous bit is positive, then present sequence you have to, these zeros, 3 zeros you need to replace with 0, 0, 0, positive. So you have to make use number of zeros. If suppose 3 zeros you are considering, in the sequence there should be n plus 1 zeros. Okay, so what you have to do, it is previous, based on the previous number of ones which are existing in a sequence, and what is the voltage that the previous bit in the sequence it has taken. Based on that, the present sequence you will be replacing with 0 0 0. Positive will be replaced with positive. Suppose the second case, if the number of ones are odd and the previous bit representation is negative, during the time the 4n plus 1 sequence you will be replacing with 0 0 negative ones. What are the other combinations of the sequence or the number of ones you may get? Odd sequence we have considered. Similarly, you go for even number of ones. Suppose the previous sequence. When I illustrate through this one or two problems, you will understand how exactly this HDB3 coding is. Even number of ones and the previous bit is positive, then you will be replacing the present sequence as negative 0 0 with negative. And if the fourth combination you are considering, the number of ones is even only, but the previous bit is negative. In that case, positive 0 0 positive amplitudes you are going to represent. Is it clear, students? Students, is it clear? Yeah?
Yes, ma'am.
Yeah, because you must respond. These problems, many are not there, only one or two, because the lack of time, I am going to solve one or two problems only in on each type of signaling scheme. So you have to concentrate properly. If suppose the zeros are trailing in any sequence, if the number of zeros are more than 3, then n plus 1 zeros. How do we represent in HDB3? This 3 represents after 3 zeros. What we are, so n plus 1 0 should be there to use this HDB3 coding. The first in the HDB3 coding, what we are doing based on the number of bits previously and whether the number of bits zeros and ones, whether they are odd or even, based on that the sequence will get changed, modified to this sequence. So now, what are the advantages of this conventional AMI, HDB3 over conventional AMI? So what are the advantages? Can you tell me? Because I've already explained. What are the advantages of going for HDB3 coding? Students, I have last 10 minutes I need to use for your MCQ.
Synchronization will be easy and then for long term.
Yeah, synchronization is the first problem, right? Yeah. So HDB3 prevents more than 4 AMI no change bits from being set continuously, consecutively. If there are zeros are there, so those zeros continuously with a constant amplitude of 0. That problem will overcome through this HDB3 because consecutive 3s are going to be replaced with the change in the position amplitude. So therefore you will have, these are the advanced. Synchronization will be easy and consecutive ones with the changed bits will be representing in HBD3 so that long runs of zeros will be avoided. So these advantages of HDB3 coding over conventional AMI, it has been asked in one of the question paper, that is December 2018 to Jan 19 for 4 marks. So these 2 points you have to write for this HDB3. Now let us go for one problem. So this problem 1, let me take coding pattern. Look at here the coding pattern, that is 1 0 Yeah, problem 1, 1, 0. What is the sequence that you have? Please look at here. 1, 0, 1, 0, 0, 0, 0. How many zeros are there? 5 zeros. 1, 1, 0, 0, 0. 4 zeros. 1, 1, 1, 2, 3, 4, 5, 6. This is the sequence to be represented in or signaled in HDB3 coding. So how to start with this? Can I write here itself? Yeah, first we'll take the bipolar representation. Bipolar non-return to zero representation. For that, what is the binary data that has been given? You first write it in the graph. So now if I go for this binary data, totally how many bits I have? Almost 21 bits I have. So what I'll do, I'll divide this into 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah. So what is the binary's first bit is 1. Next is 0. 1. How many zeros? 1, 2, 3, 4, 5. Next 1, 1, 0, 0, 4 0, 0, 0. Next 1, 1, 6 zeros. 1, 2, 3, 4, 5, 6. So every bit has its fixed duration. Please make that duration fixed, because coding should not create any problem once you plot the signaling format. Each bit is having how much duration? Students, each bit is having how much duration? Yeah. Now let me go for pen color change. Okay. Yeah. Now what I'll do here, first bipolar non-return to zero. If I take this one as positive pulse, so I can write positive. Is it clear? So then, yeah, it will go 0. Bipolar non-return to 0, right? Next bit is 0 and next bit is 1. So it will go with a negative amplitude. Then 4 zeros straight it will be. Since its previous amplitude is negative, the next bit's amplitude will go as positive and negative. Then it will go for 4 zeros, then positive, negative, then it will be 0. So this is what the bipolar non-return to 0 coding. Now we have to go for HDB3 coding, means 3 zeros, consecutive zeros as a reference we are considering in this particular coding technique. So when you look at this particular coding technique, so what is this first coding, first bit? It is 1 only. So what I'll be doing, width and plus A, amplitude I am using. Okay, if you have plus A. Next bit is 0, so 0 only. Next bit is 1, so it's inversion, Markov inversion I'm doing. Next is what? How many zeros we have? We can see here. Please talk. 5 zeros. Previous to this, how many number of ones are there?
2.
Yeah, 2. So therefore, even number of ones. Number of ones equal to how many? 2. So which one? Whenever even number of ones are there, and if its previous bit is negative, what will be now the present? What is the signaling format for these 4 zeros to represent? We have to use
Positive 0, 0.
positive. This should be positive. This should be 0, 0, and this should be positive, right? Correct, huh?
Yes.
So now previously it has left with minus a. Now positive pulse means it will shift to plus. Then next it will go to 0. Next also it will be positive, and then 0 followed by it's 0, right? Next bit is what? Next bit 1.